Yes, diversity factors can sometimes be applied to either the heat or the motor when calculating variable air volume, or VAV, breaker sizes. For heat diversity, consider large multi-zone systems. In buildings with numerous zones and a large central heating plant, it is unlikely that all zones will demand their full heating load simultaneously, therefore you can apply a diversity factor to the total heating load to account for this. Also consider variable load systems. VAV systems with variable loading patterns may experience fluctuations in heating demand throughout the day, meaning that you can consider a diversity factor for the heating load based on historical load data. For motor diversity, consider multiple motors. In systems with multiple fan motors, it is unlikely that all motors will operate at their full load simultaneously, where you can apply a diversity factor to the largest fan motor to account for this. Also consider ventilation air. In VAV systems, the ventilation air fan typically operates continuously at a lower load than the heating or cooling fan, therefore you can apply a diversity factor to the ventilation air fan motor. Diversity factors are generally determined based on engineering judgment and experience. However, the following guidelines can help. Firstly, for heat diversity, use 0.70 to 0.90 with low values for larger systems. Secondly, for motor diversity, use 0.80 to 0.95 with high values for multiple motors. There are limitations. Diversity factors should only be applied when there is substantial evidence to support their use. Diversity factors must not be double-counted or applied in a manner that would reduce the calculated breaker size below the required ampacity. Consult with the local electrical authority for specific requirements and guidance. Here's an example. Consider a VAV with a heating load of 10 kilowatts and a fan motor load of 3 kilowatts. Using the National Electrical Code, or NEC, requirements of 100% heat and 125% motor, the breaker size would be calculated as follows. Breaker size equals the quantity of 10 kilowatts times 1.0 plus 3 kilowatts times 1.25 divided by 240 volts, which equals 46.25 amps. Applying a diversity factor of 0.80 to the heat load changes the calculation to this. Breaker size equals the quantity of 10 kilowatts times 0.80 plus 3 kilowatts times 1.25 divided by 240 volts, which equals 39.375 amps. In this case, the diversity factor reduces the calculated breaker size to a more appropriate value.